Hello everyone. In this example, I will show you how you can use boosting to improve your decision trees. We use the same example that we had in the example with bagging, so I'm just going to copy paste that part of the code. So it's here where we have the training and test dataset. This is the training dataset, and we also create a test dataset that we will use later to set some hyperparameter. For our controls in the tree, I'm going to use a deviance of 0.001. I make it larger compared to what we did in bagging because I don't want to have that overfitting issue at this point. We will come back on that later. If we want to use a boosting for our decision tree, we have to tell what is B, the number of iterations of decision trees you want to fit. And I have my prediction of my training data set in f.I, but I'm going to update, overwrite the values in f.I with each iteration. So in this case, I'm not going to define f.I as a matrix, but only as a vector. So what we have here is that f.I is a vector with zeros, a zero for each training observation. It means that my initial prediction is just the mean of the target variable, it's 0. If I predict with a constant 0, then my residual is equal to the data itself, equal to y. I take my lambda, the learning rate, equal to 0.1. And then I'm going to start my for loop. So let me run this. And then we have the predictions in f.I, which are based on 1000 individual trees. And here you see the results. We have in this plot the training observations in circles and the predictions in blue dots. And here you see the residuals. Let's have a look what happens in each iteration step. So I start again from 0. We have an initial prediction f.I equal to 0. So if I then look with this simple prediction at my plot with the data and the predictions and the residuals, you see that we start with the data and a prediction that is always 0. It's a constant. So it's the simplest model that you can imagine. But based on this model, this will be the residuals. It's the same as the data. That means that we cannot predict anything. Then in the first step, we will fit a tree on these residuals and update the predictions. And then you see that we do a bit better. We can predict the observations a little bit better. So you see it goes up, down, and up again. That's better than that constant 0. But you see in the residuals, there are still very strong patterns. For example, here, for values that are relatively small, my residuals are always positive. So it means that I can build a model that tells me, well, if you have values in this neighborhood, then the residual will very likely to be positive, meaning I'm going to increase this prediction. Instead of using this prediction, I will add something because it's more likely that the residual is positive than that it is negative. The opposite happens here. So if I do a next iteration, I take into account this pattern in the residuals, and you see that the predictions move in the right direction. Each step, the model will learn what goes wrong by looking and fitting the residuals, and it will include that information in the predictions using the lambda, the learning rate. What you also see is that by adding more decision trees, so by increasing B, each time you better fit the training data set, so that's good news. Of course, we know that having a very good fit on your training data set could also lead to overfitting. So we have to set the number of trees that we want to use, so B, in such a way that it avoids overfitting. If we want to investigate overfitting, we have to look at the test data set. So I'm going to change my control here because now I can allow for overfitting, because the whole point is to see what happens if we overfit the data. So I take B equal to 1000. I now have a training and a test vector for my predictions. So what do I have here in these first three lines of the for loop? First, I fit my decision tree on the residuals. Then I predict all the training observations and I predict the test observations. Based on the training observations and the predictions, I can update my residuals. And then I again fit a new tree on the residuals. So here in the last line, I calculate the root mean squared error. I have my predictions f.e.test, which are updated here using the model, the predictions on the residuals, and I take the mean squared error between the predictions and the data. If I make a plot of the root mean squared error, you see that it's very large for small values of b, then it decreases, it reaches a minimum somewhere here, but then it starts increasing again, which shows that in order to set the optimal value for b, the number of decision trees that you use, we need to use either a test dataset or cross validation, because otherwise we can have overfitting of the decision trees, of the boosted decision tree.